kx lx is equal to 0. And what does it mean? When this domain is equal to 0, when it will be equal to 0, we know that sine 0 is 0. We know that sine pi is 0, sine 2 pi, 3 pi, and n pi is equal to 0. So I can say that this is only true when kx lx is equal to either 0 or this is equal to when this thing is equal to 0 or this thing is equal to pi times nx or n times, so I will write label x with this and pi with this, such that nx is equal to 1, 2, 3 and so on. So the only possibility is that this thing is equal to 0. It is only true when this term is equal to 0. Or this term is equal to n times pi, nx times pi, where nx will have integral values. Now look here, that this value, the very first one, when I say that kx lx is equal to 0, then either k is 0 or l is 0. I know that l is non-zero because we are having some. L is equal to 0 on the origin. We are having that value already, that gave us that constant equal to 0. So kx, now kx is also dependent on lx because k is a wave vector which is 2 pi over this lx. K, we know that k is a wave vector. This is 2 pi over the length, and length here is lx. So this lx equal to 0 will mean kx undefined. So it means that we will have to skip this value because this we have already calculated here. And the only possibility is that kx lx is equal to n times pi. I am writing as I am doing for the x, so I am writing x label with this. And similarly, it will be true for all of them. Ky will be equal, ly will be equal to ny pi. And kz, lz will be equal to nz times pi, where n will have integral values. So I can write from here that similarly ky and ly is equal to pi times ny, where ny is equal to 1, 2, 3 and so on. Like kz, lz is equal to pi times nz, and nz is equal 1, 2, 3 and so on. So I have solved the differential equation, and the differential equation will be sine, and it will be sine equals to, let me write this one. We have written sine is x, y and z here. So now I have found x of x, y of y and z of y. So I can now write my wave function. The final solution, I will write sine when I will multiply this x this y and the z components. So I can write that this thing is equal to, and when I find the normalization constant as well. So from here, when I find the normalization constant as well from the equation, the other equation will become x of x ax sine kx. And now I normalize this wave function. And we know that how to normalize this. Do this yourself, how to normalize this one. It will become psi is the normalization condition is that we will have to make this x of x is a function, mod square dx will be equal to 1, and this will give us the normalization constant, which is ax. Similarly, we will find ay, az and all this, and I can write the wave function is sine nx is sine nx ny and nz equal to 8 over Lx, Ly, Lz and square root and sine of nx pi over Lx and x here, then sine of ny pi over Ly and y here, and sine of nz pi over lz and z here. So this will be our wave function, and our energy will become from here. Our energy, total energy will be the sum of all these energies like Ex plus Ey plus Ez. And here I will write Ex, it will be h bar square k square kx square by 2m, and I will put the value of k from here, which will be nx pi over Lx. So the energy will come like this, the energy, total energy is equal to h bar square pi square over 2m, and this is nx square over lx square plus ny square over ly square plus nz square over lz squared. So this way, our energy like this, because this is the k square from here is equal to nkx square is equal to nx square pi square. So pi square I have written here, h bar over n, h bar square over 2n from here, and then it is divided by lx square, so lx square and y square and lz square, and this is the energy of our system. We calculated for a spherical system here with length lx, ly and lz. So now onward we will start with this wave function and with this energy, and we will derive further calculations toward the free electron case. So our wave function came out to be sine nx ny nz, and this is equal to 8 over lx ly nz sine of nx pi over lx and x and sine of ny pi over ly and y and sine of nz pi over lz and z axis. So this is our wave function, and the energy of our system, which is E, and it's a combination or summation of the energy along x, y, and z axis, came out to be h bar square over 2m k x square plus k y square plus k z square, and this is equal to h bar square k square over 2m, and if we, where k is our wave vector, which is kx, ky, kz. Similarly, if I put the value of kx, ky, and kz, then this is equal to h bar square over 2m pi square, and here I will write nx square over lx square plus ny square over ly square plus nz square over lz squared, and this came out to be the energy of this. Now I can plot this thing over here, that if this is our reciprocal space, now as I know that I am talking in terms of the k space, and k space is our reciprocal space, because kx is 2 pi over lx, and we know that here we are having this 2 as normally we write k 2 pi over lambda. Here this is nx and pi over lx. So it's this is space, the real space, and kx is a reciprocal space. So this will be the reciprocal of it, and here if these are the reciprocal space axes, then I can plot the kx here, ky here, and kz here. I can do like this, but it is a good representation to be like this one. Now here I am having kx equal to pi, means when I plot kx like this, then I am having the values of kx like here. This is the 3D k space, and its lengths are kx, ky, and kz here. And when I write kx, then I am having pi over the first value of it will be pi over lx, then 2 pi over lx, 3 pi over lx, because nx is changing 1, 2, 3, and so on. And similarly, the value of ky will be pi over ly, 2 pi over ly, and 3 pi over ly, and so on. And the value of kz will be pi over lz, 2 pi over Lz and 3 pi over Lz and so on. It will go on. So if I consider inside this sphere, this cube, and on this cube, let's say I'm having the electrons on each corner. Now this cube is having this is kx, ky, and kz here. So the very first cube will be on here. Let's say let me plot here, although it will be hard to be visible, but I can plot here. Now this one is on pi over Lx. Similarly, the next one here will be on 2 pi over Lx. This one on 3 pi and so on, these cubes. Similarly, this dimension of this cube will be pi over Lz and 2 pi over Lz and like this. And on this axis, means the y-axis of this, which is this one, it will be on pi over Ly, 2 pi over Ly and so on. So each of them means when the second cube will come in, then it will be on the x-axis on 2 pi over Lx, on the y-axis 2 pi over Ly, and on the z-axis it will be 2 pi over Lz, while the third cube, fourth, and so on. So this way I will fill up this whole sphere. And with this, I will now see that if I consider electrons on the corners, then this one is having joining on this side, up, down, and this side. So each here, if this electron is here, then this electron is having a joint on 4 sides here, means it is connected, this electron is connected this way, it is connected this way, and it is connected this way. So on 3 axes it is having a connection here, and this is the 4 axis connection here. And similarly above this one. So per one cube, I'm having, if I consider one electron in one cube, then on the other and on the other. So one cube will represent one electron. And if I consider the electrons on the corners of it, then 1 over 8 of the cube is having an electron. So this is the calculation, and this I will explain more as well, that how you can write this one. So let's start that I am considering each block here. So each block or each cube, what will be the means in this grid? Now I can see the inside here, that there are these electrons here, and each cube or each block is representing the distribution of electron. So I can write that the state or the electron, if it is occupying one cube here, then what will be the volume of this cube? The volume of this cube is, for example, here, pi over Lx is one side of it along x-axis, pi over Ly is the next side of it along y-axis, and pi over Lz is along the z-axis in k space. So I can write that volume of in z space will be, in the k space will be kx multiplied with ky multiplied with kz. This will be the volume in the reciprocal space. In real space, we will have the volume is Lx, Ly and Lz. That will be the real space volume. So I can write pi over Lx, pi over Ly and pi over Lz. And this is equal to pi over pi 3 pi, so pi cube. Lx multiplied with Ly multiplied with Lz, this is V, which is the real space volume. So in K space, we will have the volume equal to pi by pi cube over V. This is the volume in K space of a given block. And this whole system is made of these connected blocks. Now let's suppose that our solid that we are considering, our solid is having total of n atoms. Means the piece of solid that I am considering is having n atoms, and let's say each atom is providing q free electrons. Each atom is providing q free electrons, and we say that all the electrons are in the ground state. There are no thermal agitations. So they are having, means this is a completely isolated system which is taking energy from nowhere, and the electrons all will lie in the ground state. Now if, for example, we were having these particles as distinguishable particles, or we were having these as bosons, then in both the cases, when we were having distinguishable particles or we were having bosons, then all the particles will be in the ground state, which is psi 1, 1, 1. But we are dealing with the electrons, and all electrons cannot lie in the ground state, because we will then, means in one state the maximum number of electrons can be 2, one with spin up and the other with spin down. So the Pauli exclusion principle is compelling us to distribute the electrons.